All right, there we go. So yeah, most of you, have only had me in online classes, so you don't realize that usually when I teach in person, I wear a suit every day. So I thought I would dress up for the last day of class here, just for the heck of it, right? Welcome to our last class for CSE224, which is exciting. Um, Most of you are doing the 200 level sequence for CS, which means I'll see you in winter quarter in a few weeks, and I'll see you for your final exam, of course, on Monday. Um, but um, but yeah, it's been really great working with all of you. I think everybody here has put in a huge amount of good hard work, and my perception is, people have learned a lot, and are in good shape to move on to 222. So looking forward to doing data structures in C with you come January. My basic plan for today was to basically do a quick review of the course, and I posted a kind of study guide that's way too huge to possibly learn for the first time, but hits the highlights of what we've been doing. Let's start with any questions up front, though. Anything specific that you want to go over before I kind of jump into that general list of topics? How much about processes is going to be on the exam? Okay, here's what I'd like you to know. So let me tag this. I would like you to know what the fork command does, right? It clones a process. What the fork command returns, it returns either 0 or the ID of the created process. I would like you to know that when we want to make a new process, we first do a fork to make a clone, and then we do an exec. I'm not going to ask you about the arguments to exec, but I want you to know that that's the pair of calls that we make to create a new process. Basically, do a fork to make a clone, and then exec to change that cloned process into some other process. You should know that there's process IDs associated with a process, that there's a PS command that will show you information about processes. You should know about using an ampersand after a command to run it in the background, Control Z to suspend, and once a job is suspended, BG to run it in the background, FG to bring it to the foreground, and jobs to show you a list of jobs. So high level concepts, ways that we interact with processes from Bash. Nothing low level nitty gritty, no programming, things like that. So probably conceptual questions. Let's see, someone said GUIs are my weakest area, but I'm going to study up on that over the weekend anyway. So yeah, we use the dialog command to make GUIs, and I'd like you to know, basic interactions with dialog. I'm not going to ask you to, recite how do you pop up a text box with dialog, or how do you create a calendar command with dialog. But know that dialog is a command that we can put, switches on to pop up different kinds of boxes, and know how to capture the output from the command by putting it inside back quotes and then doing that, output FD at the end. How much code will we be writing? So there will be 3 programming questions, 1 in C, 2 in Bash, and then there'll be some multiple choice, fill in the blank matching kind of questions. Let me look at my notes off camera here. I did this once in class. Somebody asked me about the exam, and so I turned off the projector so I could look at my exam on my laptop without the class seeing it. But I forgot the fact that I was recording the lecture, and so anybody who watched the lecture saw like a preview of the final exam. And nobody told me about it until afterwards. One student mentioned it to me. So I won't do that this time. So 3 programming questions, which will be 60 points, and then 40 points worth of fairly short answer, fill in the blank kind of things. That's what I'm looking at right now. The C program will require you to deal with command line arguments, so make sure you know argc, argv, make sure you know how to use scanf to convert from strings to integers. The bash programs, who knows? But be able to do input from the user, be able to deal with command line arguments, write loops, all that sort of stuff. All right, other questions? Wow, this is still up from yesterday. That's weird. All right, so this is on Canvas, and this is fairly generic, right? But this is basically what we've been doing. So definitely, you know, all the Unix commands that you've hopefully been using throughout the quarter, because you've hopefully been working in a Unix environment from the command line. So you shouldn't have to study anything for these. So, you know, echo, cat, copy, move, remove, list, simple switches on commands like ls-l. OD we haven't used a lot. That's octal dump. That's just a nice way to look at non-printable characters. Word count, right? Date, things like that. Thank you. So all the basic Unix stuff, and if it's not on here, it doesn't mean it's not something I might ask you. But, you know, basic command line interactions, making a directory, moving into a directory, stuff like that. All right, Git. My understanding is that we've been using Git all quarter and that everybody is pretty comfortable with Git at this point. So what do I want you to know specifically about Git? The init command to create a repository, right? And you do that exactly once per repository. You don't do that anytime that you make a change. You just do that once to create the local repo. Git add, git commit for pushing changes into the staging area and then pushing them into the repository. And then if we want to work with a remote repository, git remote add origin, you know, git at gitlab.com /username/repo.git. That thing, right? Put it on your notes if you don't remember it. And then git push origin master pushes things over. That's the basic workflow that we've had to use to, you know, put a project under git control and then periodically push it out to a repository at GitLab. There's other things that you might want to know beyond this in general, but this is all I'll ask you on the exam, right? But you want to know how to do a git pull and maybe do some branching and check out and stuff like that. All right, standard in, standard out, standard error. Those are our three main streams that we work with. And, you know, we've talked about them throughout, including recently. So redirecting standard in, standard out, standard error, so greater than redirect standard out. So command greater than file sends the output to a file. Command less than file reads input from standard in as coming from that file. Greater directs standard out, but it appends to a file. Using a pipe to connect commands. So pipe connects standard out of one command to standard in of another command. So C1 pipe into C2, basically the output of the first command becomes the input of the second. And so we have, you know, all these things we do, like, you know, who pipe into word count. So that'll tell us how many people are on the system, one user per line, and word count will tell us how many lines we have. And so that would, you know, tell us how many users are on the system. And we could do a word count -L if we know that switch, or we could pipe this into awk and print field 1 if we just wanted the number of lines. And if we wanted to set that into, you know, a variable, you can put the whole thing into back quotes, etc., etc. So all those kinds of interactions. All right, so quotation marks, single, double, and back quotes, right? So these are ways that we can group things together. And single quotes and double quotes are almost the same, except if you put something inside single quotes, dollar signs are not evaluated. So if I say quote, x equals $x, this will replace this pair of symbols with the value of x. If I say single quote x equals $x, this is just 4 symbols, x equals $and x. So if you want to suppress the evaluation of things like $, put yourself in single quotes. If you want to evaluate those things, put yourself in double. Back quote does something entirely different. It says execute whatever's in here as a Linux command, right? Send it to the shell, but then capture what it sends to standard out, and that's the value of this expression now. Yeah, backticks are also not evaluated inside single quotes. Single quotes suppresses most of the interesting evaluations that we might do. So $, back quotes, things like that are just plain old characters. So if you really just want to output a string and it's got special stuff in it, throw it inside single quotes. All right, let's see. I always forget what git checkout does. I'm always using git status, git restore, but never git checkout. So we haven't really used checkout in this class, but if you create branches in Git, right, you can do a Git branch and put in the name of a branch, and it'll basically create this parallel universe for you, and you can move from one universe to another by saying git checkout. And so it lets you do, have a master branch and a development branch, and then maybe a series of issue branches, and you can move around between those. They're really useful. They're just not something we've had to do usually as just single developers. All right, what is a shell? So you should understand the concept of a shell. It's a C program, but it's running and picking up what we type and executing commands usually in response to it. So the shell we use is bash. There's a bash RC file that we can use to put initialization commands inside, so that every time we start bash, it runs all of these commands for us. You should know about the shebang, the first line that you put in a script, and if you type the name of the script, it will run that command that's listed after the $! as the program to process the contents of the file. So almost always, except for once 2 days ago, we do $!bin/bash, and it just ensures if someone's using a different shell, our script is executed with bash. Aliases are just a useful way to define one command to do something else. So alias, something equals blah. If I type something, it means blah. Let's see, but isn't that what git switch is for? I don't know what git switch does. I know, the tiny little kernel of Git that I know, and like most things, there's probably multiple ways to do things. But I don't know what git switch does. Maybe it creates a branch if it's not there. I don't know. But I'm not asking about them anyway. But if you figure out the difference, let me know. Processes, so we talked about this a little bit already. So, using an @ sign at the end of a command to run it in the background. Control-Z suspends a job. It doesn't kill it. Once it's suspended, we can put it in the background with BG. So command Control-Z BG is effectively the same thing as command ampersand. FG brings a background job to the foreground. Kill lets us kill a job. We can say kill %job number if we know the number of the job. We can say show. We can say jobs to see the list of jobs. We can kill with a process ID, and so on. And then PS is the command for looking at processes that are running. And I'm not going to ask you to know a bunch of switches for PS. Again, conceptual questions. Fork we just talked about in the beginning. So what to do, it makes a clone of the process. It returns either a 0 or the process ID of the new process. And then more general concepts about process we also talked about in the beginning. So the idea that you clone and then you use some version of exec to create, to morph the cloned process into something new. Let me see something. let's see, what else? File systems. So, there's a hierarchy of files starting with /, which is the root directory, and working its way down. There's always two files in any directory which are called dot and dot dot, and we can use these to refer to the current directory and to our parent directory. So, if I'm under, say, /home /nic/224, if I'm sitting in this directory, then dot refers to my current directory. Dot dot would refer to /home/nic. If I'm sitting here, then dot dot refers to /home, and so on. If you're sitting in /, that's both dot and dot dot. You can't move above the root directory. If I want to move down, I have to say what directory I want to move into. So if I'm in nic, I could say cd224, and it'll go down into that subdirectory. PWD shows you your current directory, right? Print working directory. CD without any commands changes you to your home directory. Tilde is also a shortcut for your home directory. Hidden files are files that start with a period, and the only thing special about them is by default ls doesn't list them. So files that we need to have around but we don't necessarily want to see, .bashrc, .git, .gitignore, things like that. Those are hidden files so that they don't pop up every time we do ls. You should know about file permissions and about chmod to change the file permissions. And just remember that basically there's read, write, execute permission. And this is for the owner, this is for the group, and this is for the world. And so you can say, I can read, write, and execute, and people in my group can read and execute, and the world has no access to my files, unless you're the owner or the group. And these are, ones and zeros. And if you make an octal number out of these, like in this case 544, that's what I can use as an argument to chmod. Yeah, it's user group other, technically. I think owner group world is an old operating system. Let's see. Variables. So variable name equals, and then whatever you want it to be equal to. Can't have spaces in here, right? I'm not going to do a lot of brutal syntax checking, but don't put x space equals space hello. It will give you a syntax error. If I say x equals 2 plus 3, x is equal to 2 plus sign 3 characters. If I want to evaluate an expression, $paren 2 plus 3. All right. If I want to evaluate a variable, $ followed by variable name. If x is equal to hello and I echo x, it just says x. If I echo $x, it'll say hello. These variables are local to our current shell. If I create a new shell, or if I run a script which happens in a new shell, and I ask for the value of x, it's not going to be defined, because these are pretty much local variables. So if I want my variable to be global to all subshells, we can export it. That's not something we've done a lot of. Built-in variables, so when you run a command, like a script, you can get to your arguments with $1, $2, $3. Okay, so those are taking the place of argv. $number tells us how many arguments we have. $0 gives you a list of all the arguments. $$ shows you your process ID. I won't ask you about that. $? Shows you the return value from the previous command. Right, and that one's extremely useful when you're writing a script and you're executing other commands and you want to know if they succeeded or failed. If you want to know if something's contained in a file, you can run grep and then check $? All right, dialog command, again, basic usage and how to capture the output. I'm not going to ask you about details. GCC, you should know how to compile a C program. Might be a good idea for this course. So GCC, the -O switch. The -O switch lets us specify an output executable instead of a.out. -C says only compile to a .o file. Make the object file, but don't link it. -G says I want to use the debugger, so include debugging information. -LM is an example of a library that we would list at the end of the GCC command to say include the math library in that case. Dialog I mentioned in the beginning, don't sweat the details of it. I'm not going to ask you, to make a text box with these dimensions and this color and all this kind of stuff, but you should recognize dialog commands. You should know how to capture the output that a command returns. All right, Gdb Debugger. We haven't done a whole lot with Gdb yet, but we will in winter. So basic use of Gdb, right? How do you start a debugging session? Well, first you have to compile with a G switch. And then if you want to start debugging, it's Gdb, and then, the program name. And that brings you to a prompt. And you can say start. To begin the debugging process, you can say break, and you can put in a function name or a line number, right? And it will stop execution when it hits one of these breakpoints. You can say continue to have it continue running. You can say step or next. This is an over, this is a step over, this is a step into. So if I say step and I'm about to make a function call, I'll go into my function and come back to the debugger. If I say next when I'm about to make a function call, the whole function runs and I come back to the next line after the call. So engineering 270, step over, step into from the debugger. But basically these are ways to single step your code. You can say print an expression to look at the value of an expression. Including a variable or a function call or operators applied to variables like size of and so on. You can say list to list out your source code. You can say examine to examine memory. And we haven't done too much craziness with this yet. Mostly we've been doing this to run our code and stop at a point where it's misbehaving, the beginning of a function, or where it's getting a seg fault or something. So we haven't done a whole lot, with examining memory and digging into those kinds of details. We will. But know the basics, how to compile with a G switch, how to start Gdb, how to run your program step by step, set breakpoints, print variables. All right, makefiles. I want everybody to be able to create a good functional makefile, meaning that it's not just a GCC command that compiles everything, but something that includes dependencies, so that if I change one file and I say make, only the necessary pieces get rebuilt. So I may give you a makefile and ask you to make changes to it. I could ask you to create a makefile. So just have a sample makefile available in your notes. Regular expressions, so we've been using these throughout. We use these with dialog. We used them a lot in homework 8, and we played with them in detail yesterday. So basic pattern matching, anchoring, using registers to do replacements. And if you can do the things that we were doing yesterday in class, you should be fine with regular expressions. Sed, mostly we use this for doing regular expressions, but we played around with a bit of the syntax. I'm not going to ask you to write a sed program, okay, but I might ask you what a sed command does, right, like a one-line program. And then the same thing with awk, right? Mostly we use it to print fields in our examples in this class, but it can do more. I won't give you a big long awk program and ask you to do stuff about it. I won't ask you to write an awk program. I might show you, a one-line awk command and ask you what it does. All right, bash programming, shebang, writing comments, different $ arguments, getting return value from a prior command, variable assignments, if-thens, if-then-elses. Okay, know how to write these, and I'm still sticking to my dogmatic insistence. If space bracket bracket space your condition space bracket bracket new line, then body of the if statement ending, right? Or else body ending, or if new if statement, and so on. Okay, got to see, you know, if space bracket bracket space your condition space bracket bracket. Your condition, if you're comparing strings, should be either equal, equal, or exclamation mark equal. If you're comparing numbers, should be one of the 6, EQ, not equal, greater, equal, and so on. Yeah, so yeah, write them like this. If you slip up and you put the semicolon then on one line, I'm probably not going to ding you. But as soon as I say that, it becomes a slippery slope, and then I start getting all kinds of strange if statements that may or may not work. So humor me. Go ahead and put them on separate lines. Let's see. So if statements, while statements, while space bracket bracket space condition space bracket bracket new line do body of the while loop followed by done. All right. So you know, there's a programming guide that's been posted on Canvas, shows you exactly what the acceptable syntaxes are. Put that in your notes. Stick with that. No for loops except for variable and list, which we did with associative arrays. I don't want to see, you know, for paren I equals 0 semicolon, etc., etc. So if you have to do any looping, use a while loop. Variable assignments and interpretation, so, you know, putting things inside back quotes, putting things in single quotes, double quotes, we talked about that. $paren to do arithmetic. Okay. Read and echo, so everybody knows how to use those. And mostly, you know, think about algorithms. So I'm not going to, you know, give you 100 questions that just check whether or not you know bash syntax. I'm going to want you to do something interesting in a bash script. So be ready to come up with algorithms and write code. All right, and then C programming. Yeah, we just get through this and we're done. So basic syntax, right? Declaring variables, initializing variables, assignment statements, if, for, while, etc. You can do for loops in C, that's fine. I just don't want to see them in bash right now. So basic syntax, know the difference between declaring a variable and actually initializing it. And don't assume your variables are initialized. If you want a variable to have a value of 0, you got to say variable equals 0. Okay? And you can do that when you declare it, if you like, integer I equals 0, or you can do integer I semicolon and then later on say I equals 0. Mostly we deal with integers and characters, right? We can do floating point, double precision floating, and so on, but mostly it's integers, characters, and then arrays of those. So character is like a short int, right? It's a byte. And we'll talk about arrays in a second. Comments, know how to put comments into your code. I recommend putting comments in your code. If there's anything slightly off in the code that you're writing, if you're not sure about something, throw some comments in and say, you know, I'm hoping that this copies the first value to the second value, but it may be backwards, right? And then I know what's going on. Number sign include, know the difference between angle brackets and include with double quotes. Okay. Arrays, so arrays let us define a group of objects and treat them as a single variable. And they're implemented basically with pointers. Now we haven't gone really heavy on pointers here in this course, but you can just think of an array as, you know, this collection of stuff that we can reference with a single variable name. But you should know that it's actually an address in memory, right? So if I say integer x bracket 10, when I say x, that's actually the address in memory. where those 10 values start to be stored. The particular type of array we deal with most is a character array, which we call a string. And so a string is just, a bunch of characters stored in memory, one after another. But because arrays in C don't have any fixed notion of size, right, and that's important to know if you have an array, there's nothing about that array that tells you how big it is, how many things are in that array. So for a string, we put a 0 at the end of the array. And if we want to store, ABC as a string, we would store A and then B and then C, and then we'd store a 0 after that. And the 0 null terminator tells us this string actually contains 3 characters. All right, and then there's a few string functions you should know. String length, string compare are the two main ones. String length tells you how many characters are in the string, not counting the null terminator. String compare compares two strings and sorts them, right? Tells you which one comes before or after the other alphabetically. String copy can be useful. Copies one argument to another. But those are the main two to know, string length and string compare. Various include files, math.h if you're doing math functions like, absolute or square root. String.h if you're using these string functions. ctype.h, I'm not going to ask you a lot about that, but it's useful to know if, for example, you want to convert case from, say, lowercase to uppercase. You can use a 2 upper or 2 lower from ctype.h. All right. Integer main, int argc, comma, char, star, argv. Definitely know how to do this. This will be one of your 3 programming questions. Will be in C and will require you to use command line arguments. So make sure you understand what these things are, right? argc is the number of things you put on your command line. If you just say blah is the name of your program, argc will be 1. If you say blah 23, argc will be 2 because you put 2 things, right? And argv is an array of command line arguments. So argv bracket 0 would be blah, the name of the program. Argv bracket 1 would be 23. Okay, if you said blah 23. And the really important thing to remember to avoid seg faults is don't use argv bracket n unless you know that you have enough arguments for argv bracket n to exist. So always check argc before you do anything with argv. And if argc is 2, you can do argv 0 and 1. If argc is 5, you can do argv 0, 1, 2, 3, or 4. So if you're going to check argv bracket j, you better check argc first and make sure it's bigger than j. Let's see, someone says I haven't used string.h at all. And did I get it wrong? There's string and there's strings. I think it's just string. Should get you string length and such. So I'm just running some junk code here. Alright, so yeah, so if you try to use string length, it'll complain if you don't have string.h. And probably if you don't spell it right. Alright, there's also a strings.h, but I don't know what that's about. So let's see, so definitely know how to use argc and argv. Know how to use scanf, okay? Do not use scanf. So scanf would be, for example, if you're reading input from the user as a string and you want to convert that input to an integer. Or if you're reading a command line argument, like argv bracket 1 in our example, which should have been 23, and you want to convert that to an integer, use scanf, right? And check the return value from scanf, right, the function value, to see what scanf actually did. So make sure you know those details that we've worked on before. Printf for printing stuff out. Everybody knows how to use that, I'm pretty sure. File IO, fopen, fclose, flush, fprintf, right? So if you want to open a file on disk, use those functions. Fgetc and fgets, right, which actually work with, you know, any file that we've opened with fopen, but we usually use these with standard in. And don't ever use gets, right? And make sure you understand what's wrong with gets, which is that it has no limit on how many characters you load into the target array, so you can have buffer overflows. Know how to write a function, know how to call functions, how to pass arguments to functions, how to use those arguments inside the function, and how to return values from functions. And this is, you know, probably most confusing when we're dealing with strings. If you're passing integers, you know, it's pretty straightforward. But let's just look at a main example. So I have, you know, a username which is 32 characters, and I want to, you know, do some processing on this. So I'm going to do some stuff, and eventually I'm going to call, you know, process main. So I want to pass that to some function. I put in, you know, the name of this array. Internally, what's happening is I'm actually passing the address of the first character of this name. But we don't really need to know that. What we need to know, though, is that in our process function, so, you know, maybe I'll say I equals. So let's say process returns an integer. What do I define the argument as? I could make it a char bracket 32, but more likely I'm going to say char star. Doesn't have to be named, you know, name down here. This is supposed to be name. Doesn't have to be the same name of the variable I'm going to pass. But I would probably define it as a char star, right? Because someone else might call this function with a name that's, you know, 15 characters, or a character array that's 1,000 characters. So all I know down here is my argument is going to point to a character, which means it's an array. But once I'm inside here, you know, I can say arg bracket some number. Now up here, if I declare char star name without a size, and then I try to you know, use that as an argument to fgets, for example, I'm probably going to seg fault. So this allocates space. This does not allocate space. So if something else is going to give me the address, is going to point to a memory location where my characters are stored, I'm okay using char star. In fact, I want to use char star. But if I'm actually asking the system to set aside space and then refer to that space, that's when I'm going to come in with, you know, specifying the size with angle brackets, or square brackets. We're not going to do malloc in this course. We'll do more mallocs than we can imagine in winter quarter. All right, and then returning values from functions, just say return variable name. If you don't have a return value, if we have a function which is void, right, we can just say return with no argument after that, and it'll just return from our function. All right, and again, you know, algorithms, right? So you want to know the syntax, you want to know the mechanics of things like argc, argv, but I'll ask you to write code that will do something. So think about algorithms, some of the things that we've done with algorithms, right? The idea of a running sum. If you want to add a bunch of numbers together, you initialize a sum to 0, and then each time you get a number, you add it to it, right? So calculating an answer as the program proceeds. Using a flag to record some event that has occurred. so that we can act on it later. For example, if you're testing for primality, when you find a divisor, you can set a flag saying, I found a divisor. And then at the end of your loop, you can say, did I set that flag? And if you did, you found a divisor. All right, initialization, again, don't assume that variables are initialized for you because they're not in C. Looping, conditionals, the basic constructs of any programming language. So sequential statements, loops, conditionals. And that's pretty much it. That's a lot of stuff, but that should get you what you need. Let's see. Do you have any tips on what homework to focus on practicing for the final? I would go through the long programming assignments. I would go through the ODPs, right? But you can also just practice whatever comes to mind. If you're rusty on scanf, right? Write some code to use scanf. Use fgets to read in a line from the user, and then scanf to parse it, 20 different ways. See if you can write a script that takes in 3 integers on one line and prints out the sum of them and catches errors. Right? That's really nothing but using scanf. If you're rusty on argc, argv, see if you can write something that does the same thing with command line arguments. Sees if there's exactly 3 integer arguments, and if there is, prints out the sum. And so that's going to use scanf that you just worked on, plus argc, argv. And let's see, we've talked about websites before, where we not have to know fork. Yeah, you should know fork, you should know what it does, you should know what it returns. But I'm not going to ask you to write code that uses fork. Okay, but I do want you to know the concept of it. It clones your current process. The clone is an exact replica, except the return value from fork is different. And it depends on whether you're the original process or you're the clone process. There's websites that you can go to where you can go through series of practice problems, starting with very basic C syntax up to dealing with pointers and dynamically allocated structures and so on and so forth. There's sites with daily challenges, all kinds of resources like that are available. But really, we're not going to get that sophisticated with programming questions on here. I'm really looking for core functionality, so I think you'd be best off just spending time reviewing the basics, writing basic code, basic loops, write something that does a running sum, write something that checks some condition on input variables and responds accordingly, things like that. There's a famous programming exercise interview question called FizzBuzz. Take a look at FizzBuzz, right? If you go to an interview, definitely take a look at FizzBuzz. You can get into nuance about efficiency and so on and so forth, but just writing a basic FizzBuzz program, apparently like 90-some% of all interview candidates for programming positions cannot write a working FizzBuzz program, and that's shocking. So I mean, take a look at that. It's a few lines of code, but it's checking basic algorithm and implementation capabilities. All right. Any other questions? We've got 3 minutes left. I could start a new topic. I could talk about malloc. All right, we'll call it good here. have a great rest of the day. I'll see you in 2:15 if you're in there. If not, have a good one. I will see you Monday, 10 o'clock on Canvas. I will have the Zoom room open and I'll be on Zoom. I'll also be checking my email. So if anything comes up, right, hit me up through chat on Zoom or an email. Otherwise, you know, quiz will open up on Canvas at 10 o'clock under the title Final Exam. And any questions come up during it, let me know. Cool. I will see you then, and have a good weekend. All right, thanks.